So welcome everyone to UC Berkeley's virtual visit. This is the engineering visit today, so it'll be everything engineering. Also, happy Halloween for those who celebrate. So a quick introduction, I'll introduce myself first. There we go. So hi, my name is Casey. I'll be your moderator for today. I use the pronouns he, him, his, originally from Long Beach, California, which is right next to Los Angeles. I'm currently a senior studying chemistry, and some of my involvement on campus includes the UC Rally Committee, which is our spirit group on campus. I'll make sure to tell you guys all about spirit throughout the tour. Actually, no, I'll make sure the other guides do it. I'm just here to moderate it. I'm also part of CalStern Philanthropy, so philanthropy and making sure there's funds on campus. And then also part of IM Sports, which is like working out and just staying fit while on campus. And before we get started with the tour, I just want to do a quick shout out to our two most recent Nobel laureates or Nobel Prize winners. And it's Jennifer Doudna and Reinhard Genzel. Jennifer Doudna won the Nobel Prize in chemistry for her work in the software or in the genome editing software CRISPR. And Genzel won the Nobel Prize in physics for confirming Einstein's theory on black holes. And it's just really cool to have these two most recent Nobel Prize winners. And also being a chemistry major, I never really thought I would want to win a Nobel Prize, but then seeing Doudna win the Nobel Prize, I'm kind of like, wow, that's kind of a cool achievement. Like, I want to do that. I'm not nearly smart enough, but I want to. But now moving on to a quick the housekeeping of the tour, just to give you all the nice like rundown of what the tour is going to entail. So this is a 40 to 45 minute presentation. If you have any questions at all, please type them out in the question and answer portion of it. We can answer your questions throughout the tour, and at the very end, there is a section for question and answers. And so please type out everything. There is no chat also, so please, anything you want us to see, send through the question answers. There will also be polls that pop up throughout the tour, so please answer those polls to give us an idea of who's here with us, because again, there is no chat. And again, this visit is being recorded, but a different version of this visit is recorded and put on our website. So if you go to visit.berkeley.edu, you can see other recorded tours. And this is the engineering overview, like I mentioned. So this is different from the regular visit. If you want to see a regular visit, which includes housing and anything else engineering, sorry, I can only really think of housing. Then you go to our virtual visit, but this is just engineering from the student perspective. So there is no admissions or financial aid info. We can always direct you to the right resources though, but just not on this tour. And then finally, like I said, we're going to end with the question and answers, and we'll do our best to answer all of the questions. So with that, I'll hand it off to our two guides for the day. We have Andrés and Stacey.
Thank you very much, Casey. So my name is Andrés. I use a he, him, his pronouns. I am from Fontana, California, which is in the southern part of California within the Inland Empire. If you know where that's at, props to you, because I usually consider it to be the biggest city in Southern California that no one knows about. I am a sophomore studying political science and Spanish. Fear not, I have trained very much to be very informative, and in a past life, I actually did want to become a nuclear engineer or aerospace engineer. So I'm going to have a little bit of my own experience put into this presentation. I'm involved within several orgs on campus, Hermanos Unidos, which is a Latinx-oriented org, as well as Somos Familia, which is a nonprofit working to educate about LGBTQ issues within the Latinx community. I'm a URAP apprentice, so I've done I'm doing research at the moment, and I was also part of Hall Association. So welcome, thank you for coming to our Halloween tour, and for those who will be celebrating Dia de los Muertos, espero que les vaya bien también.
Thank you, Andres. Hi, everyone. My name is Stacey. I use the she, her, hers pronouns. I'm from Palos Verdes, California, which is where I am right now. I'm a junior studying molecular environmental biology. And outside of academics, I'm in a lot of dance organizations on campus, most notably Dance the Bay, which is a group of students that go out and teach dance to the kids and elderly around the greater Oakland and Berkeley area. I'm also involved in Greek life, as well as in an organization called MCBC DNA, which is where we basically give resources for biology students around campus. Now, with that being said, I first wanted to give a very welcome to UC Berkeley, very big welcome to UC Berkeley. I'm so excited for everyone on this webinar today. You should see a poll popping up in front of you asking, who are you? So Andres and I can get a gauge on who is on the tour today. In terms of the pictures in front of you, over on the left, you'll see a beautiful drone footage of our campus. There's a very particular place right there that is basically the Hearst Mining Circle, which I know I personally really miss walking by every day to class. In the middle, you'll see our campanile, which is our 307-foot bell and clock tower. And the view from the top is absolutely phenomenal. On the right, you'll see our Memorial Glade, which is where some students just like to chill, as you can see in front of our Dome Memorial Library, which is an absolutely beautiful library that reminds me of Hogwarts. And students like to, as you can see, listen to music, play some instruments, read some books, and just relax on under the warm sun. And then we're also celebrating our 150 years of women at Berkeley. Berkeley has been accepting women for almost for 150 years now, and that is actually super close to when we first even established our school. So women have been around campus and have really shaped our campus for a very long time. And now looking at the poll results, I see that the majority of you are seniors, welcome. And we also have some high school juniors and sophomores. I'm very excited that you're going to be learning more about the College of Engineering and the school. So now moving on to our agenda today. We're first going to start with an overview of Berkeley, basically about our campus. We're then going to go into an overview of academics and then narrow down into engineering information, student life and resources, labs and makerspaces, research, and of course, our legacy.
Thank you, Stacey. So just to talk really briefly about our history and establishment, we were founded in 1868 by the Morrill Land Grant that Lincoln passed, I believe so. And then our university was founded in 1868. We go by several different names: Berkeley, Cal, University of California. All of these refer to the same exact institution, the University of California at Berkeley. We were the first of the 9 undergraduate schools. We were succeeded by, or not succeeded, we were followed by UCLA. So it kind of gives you an understanding of how old we are if you know the UC system at all. Our mascot is a golden bear, which we truly love. We have, so that, you know, sorry. We have a lot of campus spirit relating to that. A lot of golden bears will wear their merch, will wear their sweaters that say Cal all across campus during a normal time. Our campus size is about 31,000 undergraduates, with about 4,000 of those being engineers, and then about 12,000 graduate students, with just a little over 2,000 of them being engineers as well. So we welcome everyone to this tour, and moving along.
Thank you for that overview. So now we're going to look at the 5 undergraduate colleges. Basically, you know, one of them is the College of Engineering, but we also have 4 others that you may be interested in. So besides the College of Engineering, which has 11 majors, we have the College of Chemistry, which also has chemical engineering. So just a quick note, chemical engineering is in the College of Chemistry rather than the College of Engineering. We have our College of Letters and Science, and the College of Letters and Science has the majority of the majors, with over 80 of the majors. And about 3/4 of our student body is in the College of Letters and Science, including Andrés here. So if you do have any questions, he is definitely an expert. There's also the Rausser College of Natural Resources, which is what I'm in. So I'm also an expert in that field. So if you do have any questions about that, please feel free to ask me. Also, we have our College of Environmental Design, which is our smallest college. And now, once again, another quick note about applying directly versus transferring. So when you do apply to the university, you do apply to one of these 5 undergraduate colleges. If you are undeclared, you don't necessarily know what you want to study, you can apply undeclared to the College of Letters and Science because the majority of the majors are in that college. However, if you know you want to study some field in engineering, you can apply undeclared to the College of Engineering. So there is that option. In terms of transferring, it's actually very difficult to transfer into the College of Engineering. So a lot of students who are not in that college do choose to minor in the College of Engineering rather than double major or transfer in to the college. So with that, the bottom line is, if you know for sure that you do want to be in the College of Engineering, or even know somewhat, it is more guaranteed to like apply directly into the College of Engineering than to go into a different college and transfer in.
Thank you, Stacey. And kind of just reiterating what Stacey and Casey said right at the beginning, this will be an overview of the College of Engineering. So if you have any questions regarding the College of Engineering, or maybe like even any other college that we offer here at Berkeley, please use the Q&A function on whichever device that you are on to send our ambassadors on the back end your questions. They are more than eager to answer them right away. An overview of the College of Engineering is that, or a few mission statements regarding the College of Engineering is that they work to transform the lives of their students by preparing them to become successful leaders and innovators for positive change. And they really do strive to make sure that these students are equipped to provide this positive change in society. They want to expand knowledge and create transformative technology through original research to tackle the world's biggest challenges. And as we have seen in these like modern times, a lot of it does come down to like what universities are prepared to offer students and prepared to offer those who want to take the challenge with the adequate resources to actually accomplish and defeat them. So our campus culture, and specifically within the College of Engineering as well, is that there's a lot of individuals who identify as change makers. These are individuals who want to make sure that they're able to put their own legacy in whatever kind of field or academia that they're doing, or even anything else outside of that. They want to challenge the status quo through whether it's through entrepreneurship or research and innovation, or just being that like social activist in different kinds of fields and subjects. But that's not without the compassion, passion, and social justice aspects that a lot of our students have and continue to learn from each other on our campus. Not only during Halloween are there spirits, but all year long, we have a lot of campus spirit and pride of who we are as Berkeley Bears. So this strive to be the best that we can be also leads us to make sure that we're including as many people as possible through our work to promote diversity and excellence within different communities.
That was very well said, Andres. So now we're going to look more at the College of Engineering specifically, and we'll do an academic overview. So there are 11 majors within the College of Engineering, and they're all ranked in the top 9 globally. Go Bears. Switching majors is possible. However, it is difficult and challenging depending on what major you do decide to switch in. Really quickly, a poll popped up asking, what are you interested in? So please fill that out. All right, so yes, once again, switching majors can be difficult because between each major, there are differences in curriculum, in the courses you do take. And so if you switch into a major that doesn't necessarily have some of those shared courses, it can be very difficult to finish in the amount of time you need to finish undergraduate by. With that being said, though, it is possible. So if you talk to your advisor and make a plan and make sure that you're taking all the requirements necessary, then once again, it is possible. Now, looking at the poll results, we see that, wow, half of you are mechanical engineering. Awesome. We have some electrical engineering, computer science, and some kind of engineering. That's great. If you see the pie chart, the majority of our students in the College of Engineering are EECS, so it does make sense that quite a few of you are studying or wanting to study electrical engineering, computer science. Our smallest major is nuclear engineering, with about 1.7% of the College of Engineering students being in that subject. And even smaller than that are joint majors, because double majoring in the College of Engineering is very difficult. And so those joint majors can be difficult at times. So in terms of postgraduate paths, I know this is a question that I personally ask myself a lot. What am I going to do after graduating? And there is a lot of different options you can take. These 3 are just 3 of the many. One, you can go straight into career and industry, job, and basically work in the industry. You can go to graduate school to further develop your education. I know one of my friends actually was a nuclear engineering major and then went on to get her master's with UC Berkeley again in nuclear engineering, and she's very happy she did so. We also have research opportunities. So if you wanted to pretty much, innovate and contribute to a lot of the cutting edge research that's happening, both at UC Berkeley and everywhere, we really do prepare you for that, for our in-person, our lab experiences.
Very well said, Stacey, that we prepare them for the future. And what majors are being offered? Well, let's dive right into it. So first of all, I want to talk about engineering, being an undeclared engineering major. So this is definitely an option for students who might be thinking, oh, I don't know, I want to do some type of engineering. I want to do some type of work in this kind of field, but I just don't know what. And it's completely fine. We have this option for those students who might need a little bit more time to just figure out and try new things and see what they like. So, but regarding that, they do have to choose by their fourth semester at Cal, and they have to take an introductory seminar that kind of just explains all the different types of engineering possible. So my tip and our advice as tour guides and as just like Cal students, we really suggest that you apply directly into what really interests you, because sometimes being an undeclared engineer major means that you can choose from all these different ones. That might be a little bit more competitive than just saying like going straight into nuclear or bioengineering. Now, talking about nuclear engineering, we offer it to students who maybe want to do research and development or other kinds of forms of work with nuclear engineering. In a past life, I used to want to be a nuclear engineer, and now I'm political science. So I mean, that's like a 180 shift. But there's so many different applications for it. You can go into cleaner electrical power generation, as clean as you can be with nuclear power. But that's why we want these students that are passionate and driven to make it safer and to make it better for everyone. And so we can fight off climate change, as well as providing different ways of medical isotope production against cancer, as well as different aspects that comes to like national security. So there's so many different options within nuclear engineering. Bioengineering, what I really love about, side note, what I really love about engineering is that most of the time you will know what type of engineering it is because of what comes right before it. So bioengineering, having to do with biology and living organisms, that includes yourself, for living organisms as well. And you can do research and development into new types of technology that helps to like defeat diseases or to help combat different types of viruses. I know there's so many different types of applications within the biomedical field, information technology, genetics. So this field of study is so kind of combines the two different worlds where you have biology and engineering and kind of just making it into one thing.
Like Andrés said, there's such a wide range of careers, of research that all the engineering majors basically can have. And so now I'm going to go on to industrial engineering and operations research, very long. So I'm going to call it IEOR, which is basically the study of complex systems operation and in making processes more effective, efficient, and safe. So what does that mean? There's a lot of different types of work that IEOR students can do. For example, one of my friends worked for a company that basically creates roller coasters and made sure that the rocks and decorations on the roller coasters were cool but safe at the same time, so that when, like how close can a person get to like a decoration, like given the velocity, given the acceleration of the roller coaster. So there's that, but there's also, I know a fellow UC Berkeley student worked with Amazon in creating and basically contributing to the research of drone delivery services. So two very different jobs, but they fall under making these complex systems more efficient and safe. Next is material science and engineering, which is a study of desirable material properties in terms of function, environmental impact, feasibility, and cost. So this can be in terms of packages and ensuring that the packaging of a certain object is both, the material is both safe and environmentally friendly, but also efficient in terms of the amount of material used. My friend works at a car company to ensure that the objects used to create the car are safe and environmentally friendly. So two really awesome fields of research, as well as subjects that you could possibly study.
Very much. And like I said, Stacey, usually the name right in front tells you what the type of engineering it will be. So moving on, we have civil and environmental engineering. So civil and environment, we can kind of just break it down into like what civil engineering is, but environmental engineering is, but that would take a lot of time as well, because these are very complex forms of engineering. But basically, the basic overview is that you're working with different types of natural environments and structures, and how people are moving and cooperating or interacting. That's the word. Thank you very much, Stacey. Interacting with these different types of structures, whether it's in the environment, whether it's within a cityscape, within different types of places. I know that a lot of our engineers are taught how to not only make it more efficient and better for the user, but also sustainable, because our university very much wants to push these ideas that we are able to create a world where we're not only just making it as efficient and comfortable as possible for us, but also sustainable for the rest of the planet going forward in the future. You know, we also have movements on campus where we want to be zero waste as much as possible. And this is kind of reflected down into our academics. So now moving on to mechanical engineering. It has so many different applications and projects associated with it. As we saw with the poll very early on, a lot of individuals in our presentation today are looking into doing mechanical engineering. And if you have any questions regarding that, please use the Q&A function. We have many ambassadors who are waiting to help answer your questions, whether they are big or small. Please don't be shy to forward them to us. And so kind of coming back to mechanical engineering, you're working with different types of like robotics, mechatronics, micro and nano systems, material, machine design, and application. It has so much to do with it. But you know, what really brings my eye and my attention to it is, you know, before I wanted to be a poli-sci major, before I wanted to be a nuclear engineering major, I actually wanted to do aerospace engineering, and mechanical engineering has a lot of things that associate with it. You know, you have different forms of combustion, automated manufacturing, transportation, internal combustion. Like this major really does encompass a lot. So if there's something that confuses you or you're interested in and want a little bit more specificity, please make sure that you submit your questions in the Q&A function.
Thank you. And now we're going to move on to our engineering science major. And so this major is actually really unique in a sense to UC Berkeley. It is in other universities, however, not necessarily in all universities. And so engineering science mixes two subjects or a subject and basically has more of an overview look at engineering. So we have energy engineering, engineering mathematics and statistics, engineering physics, and environmental engineering science. And so once again, it is an interdisciplinary study that uses both subjects and brings it together. And the focus is on green technology, energy systems, sciences, math, biology, and physics. And what's really cool is that a lot of the majors that we've mentioned are more application-based. You're in a lab and it's very hands-on, while this type of subject is more theoretical, more focused on studying the research. Yeah, so if you do have any more questions about engineering science, please feel free to ask us.
Moving on to our largest and most popular major by a large margin, as we saw with the pie chart earlier, electrical engineering and computer sciences. Bear with me, I'm gonna call it EECS because electrical engineering and computer sciences does get tiring after saying it for like the 5th time. So EECS involves a lot of technological problem solving when it comes to like different types of computer and nanotechnology. We have different forms of collaboration and industry opportunities for our students where we want to make sure that we allow those studying EECS to not only be able to go into like the industry, but also work with the team to figure out different, to overcome different challenges that might be posed within the technology and electrical engineering fields. So some applications for EECS would include computer-aided design. You know, let's go back to like the aerospace engineering individuals. They want to design a model airplane on a computer, but there's not technology for it. An EECS major might be able to come in and help to create this technology that shows how lift happens, how combustion happens, drag, thrust, et cetera, et cetera. So these are very practical applications. You also have different forms of study within it, like microwave, quantum, and optical electronics and circuits. That's kind of like really complex topics to me, but as what my friend who's an EECS major had explained it to me, is pretty much making computers more efficient and run better and putting them, or not even computers, but just technology and different circuits to control it. And as we've seen in this modern time, technology kind of just runs our lives and we're very dependent on it. So making it efficient and reliable is very important. And also kind of just like another anecdote and another example, the other day I was watching this video on YouTube of people making a lightsaber, and not only did they need like the mechanical engineering combustion sciences, but they also actually needed EECS to control the flow of the lightsaber and the flow of propane and making it safe, et cetera, et cetera. So you can find this applied in many, many different areas of study. Now moving on to its counterpart, or very much likely a cousin of EECS, computer science. The difference between the two would be that electrical engineering and computer science, EECS, is found within the College of Engineering. You know, when you see that engineering, you can typically assume, except with chemical engineering, that it's within the College of Engineering. And computer science is actually found within the College of Letters and Sciences, my home college. So the differences between the two is that the College of Engineering requires you to directly apply into this major because it's so popular. It's very difficult to try and transfer, but it is possible if you put enough work and determination into it, but it's very difficult to transfer into the major. Electrical engineering, EECS, focuses a lot more on hardware and software integration, with the College of Engineering only requiring students to take 4 breadth courses and different ethics and specific math and physics requirements. So with computer science, on the other hand, you go into the College of Letters and Sciences undeclared. Don't be scared, you know, you can still pursue that major. It's just that you have to get to a certain point of study and prove that you're a viable student for this major to then declare. It's a little bit more software focused. So what's going on screen with instead of like what's underneath the keyboard, it's a little bit more flexible, but you do have to take 7 breadth courses ranging from studying different cultures to art to like your biological and physical sciences. So there's a lot of differences between the two. Very much.
Thank you. That was a very clear way of describing the differences, Andres. So now we're going to go on to other opportunities in academics. We just finished our main 11 majors. A poll just popped up asking where you're joining us from. I know I'm personally in SoCal, so I want to see where all of you are from. So other opportunities include, first you have joint majors, which if you remember back to the pie chart is a very small sliver because it is a lot of work and it does require a lot of planning. And so with joint majors, you can actually get a dual degree in 2 engineering majors. It is a little bit less work per each major because in itself, completing an engineering degree is very rigorous and a lot of work. So there are joint major opportunities for certain dual subjects. Now looking at the poll results before I continue, majority you are in Southern California, awesome. And then we have actually a lot of people from everywhere, you know, throughout California, throughout the US, and even an international student. So thank you so much for tuning in today and welcome. Great, so now we have minors, which are a less course load than majors. And so this is actually a lot of people do this. I personally have a friend who is a molecular cellular biologist, and she minored in EECS. And it was just a great way for her to both have like biology, which is her main passion, as well as a background, a little more than a background actually, in computer science, coding, as well as circuit building. And it was just great because it really complemented her research. And so if you are maybe even a certain engineering major, but you really want to delve a little deeper into another engineering discipline, minor is great for you. We also have certificates. So certificates are basically a little bit less than minors in terms of course load. There's our design innovation certificate, as well as our entrepreneurship and technology certificate. So if you are interested in that, you can take a couple courses to then complete your certificate, which can be really good in complementing other research you do or other job career choices you're looking at. We also have our management, entrepreneurship, and technology program, also known as MET, which is a dual degree program that brings in an engineering field as well as business. And so you will get a degree in both these disciplines in 4 years. You cannot transfer into the MET program, but you do apply to be in the MET program as a prospective first year. And if you don't get into the MET program, you'll actually be reviewed again under admissions for the College of Engineering because it can be competitive. So that being said, if you know you want to go into engineering, but also know you're interested in business, why not apply?
Very true, Stacey. Why not apply? it's a great opportunity if you put the work towards it. So moving on to the College of Chemistry, which houses our the only engineering outside of the College of Engineering, Chemical Engineering. It has about 1,000 students. You also have to apply directly into the college because, you know, it's ranked #1 globally, like not nationally, not, you know, on the state level, but globally, the College of Chemistry is ranked #1, and I'm pretty sure our moderator, Casey, is very happy being a part of this college. So like I said, there's only 3 majors: chemistry, chemical biology, and chemical engineering. So please apply directly to it because it can be a little bit more difficult to transfer into colleges that are a little bit more popular or impacted. So if you do become part of the College of Chemistry, you'd also have a lot of resources, tutoring opportunities to make sure that you succeed within your studies, especially as a chemical engineer. You're also able to access engineering resources from the College of Engineering. So if this is something that very much interests you, please apply directly into the college. And you could be part of the group of people that say that you're part of the college that discovered 16 elements from berkelium, California, seaborgium, lawrencium, et cetera, et cetera.
The College of Chemistry, I've taken a lot of chemistry courses in the college, and it's actually such an honor, and it's so clear how passionate professors are in these classes. Great, so talking about classes, now we're gonna move on to structure and class sizes. So in your courses, you do have a lecture section, which is when the professor or lecturer lectures about the course material. You also have a section that is adjacent to that lecture that is smaller and usually run by a graduate student instructor, also known as a GSI. And this GSI basically reviews the material with you, asks discussions, questions, and just basically is there as a resource for you to ensure that you are understanding all the lecture material. We also have our lab courses that can either be separate from the course, or it can even be a part of a lecture course. And these labs generally can range from 2 hours up to 5 hours. And I personally have been in a lot of chemistry labs, and they're very hands-on. You're like wearing like a lab coat, lab goggles, lab gloves, and you're like, you know, pipetting and doing some cool experiments. However, that being said, now that there is COVID-19, our semester has looked different. Lectures and sections do apply, except virtually, and even lab sections. You would be surprised. Like at first, I thought I was in a lab course, and I was like, oh, there's no way. Like, how am I going to do a lab? But the cool thing is, my professor actually sent everyone in the class basically the grasses we were studying. So that was awesome. I got to really have a hands-on experience, even though I thought I wasn't. And we also have office hours where professors and GSIs basically have, so that you can ask any questions basically about not only the course material, but their research and why they chose to study or to really delve into the study or research that they're doing. So you can better guess or know if you want to go into that. In terms of class size, so it really is dependent on major. You know, if you're in a bigger class like EECS or bigger major like EECS, your classes generally can be like a lot of people. I know the first computer science class, which is like both CS majors, EECS majors, and like even other majors is like 2,000 sometimes. It's like really big. But there's also like a lot smaller lectures that can be around 200 people. We have iClickers that help with in-class interaction. And basically there's like multiple choice questions on the board, and you click on your iClicker to guess the question. We have similar things virtually, which are more in terms of like polls on a website. Resources, we have our Student Learning Center, also known as SLC, that basically provides tutoring, and even virtually, I get an email from them every day, basically saying that they have resources available for all students. There's the Engineering Student Services, which is more individual for engineering students. And finally, we have our four-year academic advisors, who are very important to your experience at Berkeley and really help in terms of planning your schedule and any academic troubles you might be having in your classes.
And please don't be afraid of reaching out for help, right, Stacey? Like, people should always be encouraged to make sure that they go out and collaborate and get that assistance. So regarding further assistance for students, we do have different forms of student diversity on campus that we want to make sure that we recognize, because once we recognize it, we can help them and advocate with them to better their experience in academia and within society as a whole. So we have the different programs of like Women in Science and Engineering theme program, WISE, where women in people who identify as women are able to live within a dorm or a different in a residential building, all within the same kind of like thought and being able to collaborate with one another in that kind of sense. We also have the Black Engineering and Student Science Association, BESA, Hispanic Engineers and Scientists, HES. Shout out to my friend Christina, who's in it. EOP STEM, which is an educational opportunity program for students who find themselves within the STEM majors, as well as a pre-engineering program, PrEP, where students from low-income and minority backgrounds are able to come in a summer early to Berkeley and able to take classes and get a feel for the life of an engineering student before their actual semester starts after high school. So if you please have any questions regarding our attempts to make sure that student diversity is present on campus, please make sure you use the Q&A function on your device.
Yes, very important to our student life. And now we're going to be moving on to some clubs and competitions that are maybe even run by students on campus. So we have our Cal Sol, basically a solar vehicle team where they make solar powered race cars. We have our Cal Steel Bridge team, which is basically part of mechanical engineering and a team that basically builds like bridges, tests them, and competes with other people or other groups in other schools. And what's really cool about the Cal Steel Bridge team is that their like makerspace is in a place called Davis Hall. And it's this amazing, like, it's this ginormous just workspace where people are like building like really big bridges. And it was cool is the Bay Bridge as well as the Golden Gate Bridge was actually tested there for earthquake safety. And it is a very magnificent place, and actually anyone can just look down and see what's happening in that makerspace. We have our Berkeley Formula Racing, also known as FSAE, which is a group that builds and recycles race cars to then compete with other teams. There is the Biomedical Engineering Society, Society of Women Engineers, CalHacks, which is actually planned by students and anyone, regardless of major. I personally am terrible at coding, but I still participate in CalHacks because it's like for everyone. And it's like a very fun event where people basically code for a very long extended period of time and, you know, help each other to reason through each problem. And then there's the Pioneers in Engineering, and finally our Department Honor Societies. And this is just a few. And even if you are in the College of Engineering, there are so many other extracurriculars for you to choose from that are outside of your major that I know a lot of people like to do in order to still keep up their passions that they kept throughout high school. So if you do have any questions about them specifically, please let us know.
Very true, Stacey, where a lot of engineering majors are actually in orgs outside of engineering and are participating in different areas like social justice, et cetera, et cetera. So great point, great point. So moving on to our labs and makerspaces. So these are places where students are actually able to get that hands-on physical interaction and experience with different types of engineering. So we have the Satar Jedi Hall, which houses CITRIS, the Center for Information Technology Research in the interest of society. So this is kind of just a center where students are able to do research on technology in order to like see how they're able to help better society in different types of ways. We also have different workshops, aviation and nanofabrication labs in Satar Jedi Hall. So next we're moving on to Jacobs Hall, where we have the Jacobs Institute for Design Innovation. So creating different types of designs that would help society become more efficient and fluid and comfortable for people. We have the Hesse Hall, where we have the Mechanical Engineer Machine Shop. And let me tell you, I've heard stories from many of my engineering friends who they go to the machine shop or even I think the construction bay, and they're there for such a long time working on different types of engineering materials and ideas. So it's very much like really cool that students are able to like learn how to use a power saw or learn how to cut wood and lumber into different types of things and robots and stuff. It's just super cool when you hear all these stories coming out of these construction bays and machine shops. We also have the Richmond Field Station, which you can kind of see in that picture with the nice sunset in the background, where it's this very large field where students are able to go and experiment with different types of race car technology, aviation technologies, and it's pretty much this large plot of land where students are able to experiment and do research without the fear of harming others, because safety is #1 in science.
Yes, thank you. I personally really love the Richmond Field Station because it's also a place where a lot of environmental research is happening. And so, yes, molecular environmental biology. I have a really strong connection to the environment. Okay, so now we're gonna move on to some research opportunities that undergraduates can take. So lots of undergraduate students do research at some point in their undergraduate experience. I mean, just ask Andrés, right? So we have our undergraduate research apprenticeship program, also known as URAP, which is basically a hub of research opportunities. Like there is hundreds of just faculty being like, here's my research. Is there any undergraduates wanting to help me and contribute to the research? And you basically fill out application. You can only apply to 3. However, chances are there's a lot of other students who also want to do some research. So, but that also gives you a lot of opportunities to like choose different disciplines. Like even if you're interested in biology, if you want to try something else, you can apply to that. And so it's a great way to get that start into your research before delving into deeper research later on. We have Beehive, which is actually similar to URAP, except it's more specific to engineering students. We have the Lawrence Berkeley National Laboratory, which is actually just like above Berkeley, I would say, like it's like up the hill. And it's a very awesome laboratory that's doing a lot of cutting edge research as well. And the view from up there is absolutely phenomenal. We also have the Sudarsha Center for Entrepreneurship and Technology, which is what Andres talked a little bit about in makerspaces. And we have the Collider Cup, which is basically a competition where students basically become entrepreneurs and innovate and compete with their certain technology or their certain innovation. And we also have undergrad and professional programs and research that are more department specific. So if you're a specific major, there's definitely like newsletters that come out that are like, hey, any mechanical engineering students, we have this research opportunity for you. So please like hop on board. I promise you, no matter where you look, both virtually and I mean, when I'm on campus, just like in buildings, I see like posters everywhere of people being like, we need undergraduates to help us. So lots of opportunities there once again.
And I'll quickly add on before we move on to the next slide, Stacey, that URAP truly has hundreds of opportunities for students from so many different fields. Like I'm a political science, Spanish, Portuguese major, and like I applied to programs that weren't even in my majors. There was some programs that were offered to students from any type of undergraduate major. And from the College of Engineering, you could also be an engineering student and going into like sociology research, and they give you that hands-on training so you can start doing it from like the moment you go into the program till you leave. You have these basic understandings that will help you do research in the future. So it's very much a great program for students trying out research for the first time. So we can't talk about the College of Engineering without talking about our legacy that we've had in the past, our notable figures and alumni. We have maybe some people might have heard of Rube Goldberg, or at least his machines, at 2 in the morning when they're scrolling through YouTube and they see these long complex machines of like ping pong balls rolling across a room and et cetera, finally to only make toast at the end, right? Well, Rube Goldberg was the inventor of those kinds of like complex machines, being not only an engineer, but also a cartoonist. So you can see how this individual was able to not only merge science and technology, but also with art and different types of media. We also have our Dean Liu, the first female dean of the College of Engineering. She is also an instructor, researcher, and administrator, working very heavily to include many people from minority communities within the field of engineering and providing them with adequate resources to excel in the field. We have Shafi Goldwasser, who won the Turing Prize in computer science. And if some of you might not be aware with the Turing Prize, it is like the Nobel Prize of computer science. It is so prestigious, and she was able to get it for computer science and her work within the field. And possibly the most well-known alumni from the College of Engineering, Steve Wozniak. So Steve Wozniak was a co-founder of Apple Incorporated, a company that is now valued at over what, $1 trillion, $2 trillion at this point? I don't know, Stacey. I'm an Android person, to be honest. But Steve Wozniak was a co-founder of Apple Inc. and being able to use his different fields of study from EECS and computer science, he was able to provide this technology, this resource to millions of people worldwide. Finally, we are also celebrating 150 years of women in engineering. So not only 150 years of women studying at Cal, but also being in engineering, which should always be an amazing feat to celebrate and to recognize so we can improve upon in the future.
Awesome tour, guys. Now we can jump into the Q&A. And Andres, you said you're an Android. That really is scary. Spirit of Halloween. Anyway, so the very first question is for you, Stacey. The question is, what are some popular engineering extracurriculars, or maybe just any extracurriculars, and how can I get a good balance of academic and social life?
Yeah, that's a great question. So in terms of specific to engineering, I think that those engineering extracurriculars on the slide were like probably the most popular groups that a lot of people join. That being said, I would say I met the majority of my engineering friends in other organizations. For example, AFX Dance, which is an organization that has like thousands of people in it. I've probably met the most amount of EECS people in that organization. And so that being said, of course, join any organization that you're passionate about if they're doing really cool things like building race cars or building race cars that are solar with solar panels, or building steel canoes, steel bridges. Like if you're passionate about that, of course, join. And they're great organizations. And if you do have passions outside like music, or you like to knit, or you like to watch like very specific films in the 80s. Like, I mean, any organization, there is definitely one for you. With over 1,200 organizations, Berkeley really has a awesome student life. And so there isn't really one popular extracurricular because everyone is so different, unique in their own way. In terms of balancing social and academic life, I would say the biggest tip I would have for you is that you're in college now. You have the choice to shape your schedule. You have the choice to try out new things. For example, studying in the morning, studying at night, studying during the day, which is something that you didn't have in high school. You know, high school, you had a very set schedule. You went to class at 7:55 and you ended at 3:15 to do your extracurricular and then study. It's like very much like that. And so personally, I found that I like to study really early in the morning because that's when my brain just works the best. I retain the most information for sure. And I'm definitely the most productive because I don't have my friends like distracting me at all. And then I like to have my classes during the day. And then at night, I like to hang out with my friends and basically do my extracurriculars, which are also friend time, right? And so it's like that awesome schedule that you can build, then that like allows you to do everything you want because you know when you are the most productive. And I would say, of course, you did the first step, asking us, asking your colleagues, asking older upperclassmen as well.
Awesome, great answer, Stacey. I'm sorry if my internet's being awkward. But yeah, that's a great, balancing social life and academic life is very much possible at Berkeley, especially now online. But now next question is for you, Andres, and is it possible for me to study abroad as an engineering major?
I think this question is very interesting because I've been studying how to study abroad very recently. So I want to shout out that participant that gave out that question. And also I really want to quickly comment on Stacey. You're lucky that you went to high school at 7:55 in the morning. I had to go at 6:30 in the morning. So it was very much an experience for me. But coming back and circling back to studying abroad, what I had previously thought before I did any research into it was like, no, like it's mainly for like social science and humanities majors. but in actuality, the programs coming from UCAAP, the University of California Education Abroad program, and different types of programs offered to students who want to study abroad, you're actually able to like study engineering in different countries. You know, now it might not look very possible because of the coronavirus pandemic, but in the future, when we're able to finally go outside and stop hibernating, that like these opportunities to study abroad are very much existent. Like I was looking into programs studying in Brazil and Chile, and not only did I find what I needed for my majors, but I also found like industrial mechanical engineering as well as nuclear engineering within these countries. And it's amazing to think that you're able to study in a different country, you know, whether it's South America, in Asia, in Europe, that you're able to develop these different kinds of technologies while also experiencing like this cultural exchange, which I think is very much an amazing opportunity. And there's different scholarship and financing programs that also allow for students to be able to finance this. And most of the time, insider tip, it's cheaper to study abroad than to study at Cal. Just look at the tuition sheets when you're studying abroad in Peru or in Brazil. Just say, you know, maybe think about it. That's all I'm saying.
Yes, definitely think about studying abroad. I love Berkeley too much to ever leave it. I'll probably be here when I'm 80 still, but yeah, study abroad is a very great opportunity, especially with engineering. So next question for you, Stacey, is what exactly is molecular environmental biology, and why did you choose it as your major?
Thank you so much to the participant who asked me this, because I love my major so much. And at first, honestly, when I saw the description of the major, I was like, oh yeah, what is exactly molecular environmental biology, also known as MEB? And so MEB is a major in the College of Natural Resources that basically is an interdisciplinary study with molecular biology in terms of like human health, in terms of animal health, in terms of insects. Like there's so many different concepts there, and its relationship to the environment. And so I personally am on the pre-medical track right now. And I really knew I wanted to study molecular biology and human health because I was always very interested in science as a concept, honestly, just growing up. Like even besides biology, physics, chemistry, like I just love the sciences. But then I also had a very strong pull towards ethics, towards basically the environment as a whole, because there's a lot that goes in the environment. There's policy, there's economics, there's science, of course. So there's so many things there. And when I was environmental science major at first, but I liked molecular environmental biology because of its integration of human health studies. And I just had the most amazing time learning both like super in-depth biology, like bio 1A, bio 1B, which are like general biology in terms of like plants and humans. But then I also really loved learning about like medical anthropology, about like society and environmental justice, about everything that goes on with the environment, how it's super pertinent to our health as human beings, you know, pollution, everything. It's just so connected to us and our state as humans. So that is molecular environmental biology. And the reason why I study it is because it's super interesting, and it always is a growing field where there is so much to study and learn, and you can go through so many paths within the major.
Awesome, very insightful, because as even though I am at Berkeley, I still had that question of what the heck is that major? I still have that question with some of my friends, but they always respond, they always like answer me. So another question, this question is for you, Andres, and the question is, for freshman engineering students, is it dorming with only students from the engineering college, or is it mixed dorming with other students from other colleges? And also, how do you make friends like in the dorms or whatnot? Just anything dorms.
Yeah. Totally valid question. Well, like we kind of alluded to earlier, we do have the WISE program, so the Women in Science and Engineering theme program, where you're able to stay with people who identify as women and only live in that kind of residential area. If that's something that you'd like to do, you know, all these people around you will go into engineering or some kind of science. But on the, you know, usually in the majority of the time, we actually just have students live amongst each other. You know, there's not much of a difference between a philosophy major and an engineering major, except that they're studying two different things. they're able to like interact in all the different types of dorms that we offer. If you'd like to learn more about that, please go to our virtual presentations that I believe are also on the website. And, you know, from my own experience during my summer bridge program, which was a program before coming into Berkeley, I actually dormed with a chemical engineer, and we had a good time interacting with one another and learning from each other. And these are the ways that you're able to like interact with people outside of your own field and outside of your own major, so you can learn and further experience different types of academia within the same place.
Yes, definitely. Always a mix, or you can also then, yeah, like Andres says, the WISE program. And so now finally to our last question for both of you, Stacey first and then Andres. What is your Berkeley story? Why did you decide to apply to Berkeley? Why did you come to Berkeley? What brought you here and why are you here? Just everything why. So you first, Stacey.
Yes, amazing question. So I came from a high school with a graduating class of around 60 students. And so I knew from that experience that I wanted to go to a very large school because I have so many things I'm passionate about, and I wanted to be surrounded by people, a lot of people with very diverse backgrounds and just with a lot of passions that I could learn from and basically communicate with. And so I also really wanted to stay in California. And so I came to Cal Day, which is UC Berkeley's. Oh, okay. I got my admissions back. I didn't have the chance to actually go to any of the schools I applied for. There you go. But once I got accepted to Berkeley, I basically went to Cal Day, which is this giant event where like 6 Oskies are running around. There's like Cal band, cheer, dance team just everywhere. And there's like hundreds of tents of people being like, look at this program. And just from this experience, I knew that I wanted to be surrounded by such spirited students and people who were just not only passionate about what they're studying, but about their school. And so I came, it was a little overwhelming at first, but I just met so many amazing people, joined amazing organizations. And what I love about the school is that you get that duality of being surrounded by your family that you meet, like the same, maybe 50 people that you like really like interact with, whether that be in like a dance team or like in your band, right? But you also meet new people every day in your classes, walking to school, just every single day you meet new people that are passionate about different things and that have different backgrounds. And so this duality is why I love Berkeley so much. And even online, right? Online school, you would think I would feel isolated, but I promise you, not only do I still meet every single one of my organizations virtually, I play video games with my friends almost every single day because we're just always like pumping. We made Slack channels, Discord channels to basically keep ourselves still integrated together.
Awesome. Yes, I always play Among Us with my friends. It's always a great time. Off to you, Andres.
I'm jealous, Stacey, very much that you get to play video games. My schedule is usually a lot busier. But my own Berkeley story was that I never really envisioned myself going into a very large public, let alone prestigious university. I'd never really seen anyone in my community achieve to that level. My parents didn't go to college, so I'm the first one in our family to do so. So like kind of just like envisioning that and like I never really believed in myself until I went into like high school, and I had a lot of teachers and counselors and people pushing me to do the best that I can, whether it's like just have do the best that I can in general. And like I said during the tour, I used to want to be an aerospace nuclear engineer, one of the two, but something flicked and something switched when I started to do a lot more research on what I could possibly do for my own community. And that's when I started to see like, oh, Berkeley, this place is amazing institution, is able to offer not only like the duality that Stacey was talking about, but also like meeting so many different people from so many different perspectives. Like most of the people around me are Latinx identifying individuals, but coming to Berkeley, that was very much like something different that I was able to appreciate from so many people from so many different perspectives, that I'm not only able to like see what people were able to like put on to me in person, but online as well. We're able to interact in so many different environments. And it can be difficult online and in person because at least for myself, it's something always new and something I always have to discover. But with all the help that I've been getting that I got last year when we were in person, and this year when I'm able to get like tutoring and counseling and advising from my advisors over the phone and over Zoom calls. It has very much like been worth it, putting all the effort and putting in all the work, because I know that I'll be able to make an impact within my own community someday, or hopefully now with all the work that I'm doing. But yeah, Berkeley has very much been a place where I've been able that has helped me foster and help grow my own interests while also helping out those around me.
Awesome. Thank you so much, guys, both of you, for sharing your Berkeley story, both very, very passionate. And so now I'll wrap up the tour very quickly. So thank you all for attending our engineering virtual visit. Please follow us on Instagram, or I also think also have like a Twitter for at Visit UC Berkeley. You can also email us at tour@berkeley.edu, so a student ambassador can answer your question. If you happen to think of a question later tonight, like you sit up in bed and go, oh my God, what's it like in, I don't know, in this dorm, then you can always email us. You can also go to Bear Talk blog at beartalk.berkeley.edu, where student ambassadors, they write out different stories and just like they blog about their life at Berkeley. And again, another virtual recorded visit will be available online at UC Berkeley, at Visit UC Berkeley on YouTube, engineering and otherwise. And if you want to see anything about the coronavirus, and Berkeley's resources and response to that, you can go to coronavirus.berkeley.edu. Again, we're celebrating 150 years of women here at Berkeley, so go to 150w.berkeley.edu to learn more about that. For anything engineering in general, engineering.berkeley.edu, and basically anything you'd want, you can always go to something.berkeley.edu, you can find it. And just like if you want to see more visits like that, you can go to visit.berkeley.edu. So with that, thank you for attending this tour, and me and the other ambassadors are going to send you off with a Go Bears on 3. So ready? 1, 2, 3. Go Bears!
Bears!
Thank you and have a great day. Happy Halloween and happy Dia de los Muertos, or Eve.
Yes, Casey.
I tried. Thank you all.
We're inclusive here. We're inclusive.